Welcome to the section on reciprocal functions. The objectives in this section are to confidently sketch the graphs of secant and cosecant functions, and confidently sketch the graphs of tangent and cotangent functions. The graphs of secant and cosecant functions can be derived from what we saw in sine and cosine functions. They have a period of 2 pi. But what about the secant and cosecant? Are these periodic? They should be, but how? The functions secant and cosecant have periods 2 pi, just like sine and cosine. This means, again, similarly to sine and cosine, that secant of an angle plus 2 pi is equal to secant. And cosecant of theta plus 2 pi, an angle plus 2 pi, is equal to cosecant of theta. Let's see if we can fill out the following table using a calculator. You'll need to round up to 1 decimal place when we do this, so go ahead and grab your calculator and let's give this a try. We'll make sure that we're in radians because all these angles are given in radians. And we are in radians, so we're good to go. Now we're going to take sine of these different angles. Now remember, sine of an angle gives you a distance in the vertical direction from the x-axis. And the angle is just a rotation, a measurement from standard position. And when you're comparing that with an x-axis, you're simply unwinding that function onto an x-axis. So if I have sine of 0, I get 0. Sine of pi over 6 is 1/2. Sine of pi over 3 is 0.866, so we'll round it to 0.9. Sine of pi over 2, well, I just know that one's 1 without even putting it in the calculator. Hopefully you're getting to that point. You might not be there yet, but keep working on it. Sine of 2 pi over 3. Again, 0.866, rounding to 0.9. 5 pi over 6. I hope you're seeing a pattern here. Is 1/2. Sine of pi is 0. 7 pi over 6. Negative 1/2. 4 pi over 3. Negative 0.866. And I'm going to move my calculator to the other side. So sine of 3 pi over 2 is negative 1. 5 pi over 3, negative 0.866, or negative 0.9. 11 pi over 6. If I find sine of 11 pi, negative 1/2. And 2 pi, sine of 2 pi is 0. Now let's look at the cosecant. Remember, the cosecant is the reciprocal. So if I have 1 over 0, that is so undefined. We can't do that one. Undefined. And then we need to look at 1/2. The reciprocal of 1/2 is 2. the reciprocal of 0.9. Now remember, 0.9 is the same as 9/10, so this is 10/9. The reciprocal of 1 is 1. The reciprocal of 0.9, again, 10/9. The reciprocal of 1/2 is 2. The reciprocal of 0 is 1/0, again, undefined. The reciprocal of -1/2 is -2. The reciprocal of -0.9 is -10/9. The reciprocal of -1 is still -1. The reciprocal of -0.9 again is -10/9. The reciprocal of -1/2 is -2. And the reciprocal of 0, undefined. So what is going on? Can you graph one period? Well, we know that sine has a period from 0 to 2 pi. So I'm just going to sketch the critical points. What I am doing here is I'm breaking up my x-axis into radians that are in thirds, in sixths, and in halves. And that's not super common. It takes a little bit of practice to figure this out. But first I broke my horizontal axis into pi and 2 pi. From there I broke it into pi over 2 and 3 pi over 2. So I am breaking up those intervals into halves. But then I also realized that it was asking for thirds, pi over 3 radians. All these are pi over 3s. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And so I had to break the intervals up into thirds for pi and for the interval from pi to 2 pi, which is tricky if you're working on this for your first time. And then I changed colors to blue and I said, oh, but then I need sixths. So I'm cutting the pi over 3s into halves. So that's where I got all these blue intervals here. So now everything's cut down into sixths where you can see the steps. Now I'm just going to go through and I'm going to make a dot wherever there's a coordinate point from the table. Like this. At 7 pi over 6, I will be at -2. At 4/3 pi, I will be at negative 10/9, so just over negative 1. At 3 pi over 2, I will be at negative 1. At 5 pi over 3, I'll be at negative 10/9. At 11 pi over 6, I'll be at negative 2 again. And if I connect those dots, again, I will have this curve here. You may recall from some pre-calculus class you've had that these curves, if they're tending toward a vertical asymptote, they will hug those asymptotes to infinity, or negative infinity, as the case may be. So what your big takeaway should be from this experience, although it's a little tedious, your cosecant x, this little arrow is approaches. So you would read that as cosecant x approaches infinity as x approaches 0. And this little plus sign means from the right. And cosecant x approaches infinity as x approaches pi, and this little negative sign here says, you would read that as from the left. And we can also say that cosecant of x approaches negative infinity as x approaches pi from the right. And cosecant of x approaches negative infinity as x approaches 2 pi from the left. So you should ask yourself, what is the domain and range of the cosecant of x? We can say that the domain is all real numbers except x cannot equal 0, pi, 2 pi. And can you think of a way that you could express this, because that we're also going to have to go to the left. This continues to repeat as we move to the left on the x-axis and move to the right. So we would say that x cannot equal multiples of pi. So plus or minus n pi for n as an element of or in the integers. Now notice that n could be plus or minus 0 pi, plus or minus 1 pi, plus or minus 2 pi. You get the idea. That's what n pi means. Now if we look at the range, we see that there is a gap between 1 and negative 1, where we sketched the sine function, but the cosecant function does not exist in this interval. And so the range of this function is negative infinity to negative 1, including negative 1, union 1 to infinity.